All right. Do we have any questions before I get going? All right, like I already said, if you're watching the video, there's a new camera. So on the plus side, hopefully it'll stop cutting out. On the negative side, I'm going to start walking up the wall if I walk too far away. So we'll see how this goes. It'll be fun. Yeah, any questions before we get going? Nothing? All right. Sorry? What's my second favorite color? Oh, I don't know. That is, right? Because I've never thought about that. I don't think I've ever thought. What's your second favorite color? Who said purple? You had an answer. Wow, see, that was the thing. I was going to be like, who has an answer to that question? Yeah, what's your third favorite? This is insane. But what's your first, what is your favorite? You don't have a favorite. You've got a second favorite and a third, but not a first. That's wild. That means second's number one, unless there's like a tie, and it's like, I don't know. Maybe it's more of like a tier list thing, right? You've got your S, and then, it goes, interesting. Yeah, I don't know. Second favorite. It's tricky because you can say blue, but it's like, well, what kind of blue? There's a shit ton of blues, right? Like cyan. Cyan's fun. Magenta, that's nice. It's kind of purpley, a little different. Yeah. Any other questions? Someone asked another time, I think it was Friday, and I told them to ask me on Tuesday, and they didn't, so they should feel really bad about themselves. They asked, okay, can you tell me a little bit about the test, right? Because when is the test? I don't remember what I said. Next Wednesday? It says the 2nd, I guess. Something like that. All right. People want to know, well, what do you expect on the test? Okay, here's what it's going to be like. First of all, understand that I make tests in a way. Let me take a moment to talk about the tests. I really pride myself on my ability to write good tests. I really think I'm really damn good at writing tests, because my tests are really good at drawing that line of, do you get it or do you not? And that's really what I want to measure, right? It's hard to find that in between. Either you get it or you don't. Another thing I'm really good at doing with my tests is I make them really easy for me to mark. So the reason I'm telling you this is, okay, what to expect. Put the what to expect when you ask yourself that question, put that in the context of, he wants it to be something that's going to be easy to mark. So that gives you some idea. I'll usually start with a bunch of questions that I call short answer. It'll require you to write code sometimes. And the questions are going to be variations of usually the following. Explain what this code does, which is surprisingly difficult for people because people will start explaining line by line. And it's no. What does this function do? Well, this function takes 2 parameters. No, just it converts Celsius to Fahrenheit. But if you start saying, it takes a parameter, and then it stores the value in this variable called this, and then it takes that value and it divides it by, or multiplies it by 5/9, and then it, no. Your understanding is poor. What is its functionality? Other questions are, think about it like this, right? If I give you a function, functions often take input and produce output. So questions will sometimes be okay, here's the input I want to give you, and this is the output I expect. I want to be able to give you a temperature in Celsius, and I want you to write the code to give me the temperature in Fahrenheit. By the way, if I were to ask a question like that, I would be by the way, here's the formula. I wouldn't test you on your ability to convert Celsius to Fahrenheit. That's not the point. But it would be write the code to do this. And it would ideally be something that takes 1, 2, 3, maybe 4 lines, right? It should be very small. If on any of these questions you're writing 10 lines, you're doing it wrong, okay? Sometimes I'll be here's the input, here is the code, what is the output? And you tell me. So what is your ability to understand how would this flow? And then sometimes, and these are like my favorite, here's the code, here's the output I want, what would the input need to be to give me that? So it's kind of like asking you the 3 different parts, okay? Tell me a little bit about what input would need to be, tell me what the code would need to be, tell me what the output would be. And then after that, I'll have like 1, maybe 2 questions that are a little bit longer. That'll be like, write code to do, write a function to do X, Y, Z. And it might be a little bit more involved. But again, if you're writing more than like 10 lines of code, let's say 15 lines of code, you're doing it wrong. Like these should be things that, like, if you know what you're doing, you should be able to write it like boom, 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 boom. The students that do well are often done writing the tests in like 10 minutes, right? That doesn't mean if you're taking the full time, you're not doing well. No, 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 that's not what I'm saying at all. What I'm saying is it's designed to be, like I very much designed my tests that if you know what you're doing, this should be a joke, okay? If you don't know what you're doing, this should be the hardest goddamn thing in the world. But the best part is if you don't know what you're doing, it's really easy for me to make it the hardest thing in the world for you. And if you think that's mean, well, no, that's my job. My job is to evaluate your understanding, literally. So that's kind of what it's going to be. It shouldn't take you a long time. If you're writing a lot of code, no. If you're thinking, writing code by hand, what? No, this shouldn't be that much of a big deal. I'm very forgiving. Like if your syntax is slightly wrong, I'll be like, yeah, I know what you mean. Like if you forget a colon, whatever. Now, if your indentations are all over the place and there's ambiguity on like, what do they mean? I can't tell. It could be right or wrong. Well, we got a problem. But whenever it's like, okay, they forgot this and yeah, they did that backwards, it doesn't matter. Like I'm usually fairly forgiving. I'm looking to evaluate your understanding at an important level. Like basically, if you wrote this into a computer and you hit run and it said indentation error, you'd be able to be like, oh yeah, oh, it's good. Yeah, then I'm happy, right? I look to evaluate your understanding, not to be nasty. So don't worry too much. Prepare. The best way to study is practice. And then if you're wondering what the real trick is it's just more practice. That's it. Practice, 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 practice. There's no other trick to it than that. Where do you find practice questions? Oh, there's tons. You can literally just Google some. There's a bunch in the lectures. There's a bunch in the labs. There's the course textbook, which is full of exercises. There's Caddis, which is full of exercises. There's the assignments. There's a lot. So don't tell me there isn't. There is. There's plenty that you can use to practice, and if you work through that stuff, you're going to do great. If you were to go through and work through all the textbook exercises, which might sound like a lot, but it's really not, and like you understood what you're doing, if you did that and you don't get perfect on the test, that would be weird. Like you absolutely would be able to crush the test if you can go through those exercises with no trouble. So far, only 2 people have come to my office hours from this class this semester. And we're in like, what, week 3? That's fine, you don't have to come. But I'm always wondering, I get lonely. Any questions or anything? Yeah.
In an exam setting, do you want us to put like a line of test for the function?
No, usually like for like the short answer, it'll be like write the code to assign 2 variables values and then swap the values between the variables, right? You wouldn't really write tests for that. So if I did want you to write tests, I'd explicitly tell you. Those short answer, the context of them, you would know like, okay, I'm not going to write tests for these. For so I call them short answer, and then the bigger question is called short answer because it's still short. For those, usually what I do is like what I do on the assignment where I say, like, here's the function, fill in the blank. Here are tests that would need to pass. So like I've given you the tests, and the benefit of that is like, look, obviously, the tests aren't automatically going to run. It's on paper. But it shows you, like, think about how would it have to work with a negative number, a positive number, 0. Like, it gives you a chance to reflect on, like, well, how would this work? Because, again, you could just run the code in your head. Speaking of running code in your head, let's try again. Smush. I'm sure you left last time and felt really bad about yourselves, and so today you really want to impress me. So let's try again. I'm going to call smush. We're down on line 17. I'm calling smush, and I'm giving it the argument 10. So we jump up to line 1, and there's a parameter there called a number. What value does a number get? 10. Nice. We jump down to, well, let's skip all that nonsense. In fact, here's what I'm going to do. Let's go back to this code because it's a little less verbose. We don't have all the doc strings for the sake of brevity. That first line there, line 2, it is a hilariously simple line. After it's run, what value does the variable return value have? 10. Very good. Why? Well, because a number had the value 10, and then the equals means assignment, which means take that value and put it over there. Then I say, hey, is a number greater than 0? Is 10 greater than 0? Who said yes? Try again. Is a number greater than 0? Very good. It's not yes, it's true. In fact, it's capital T true. So because it's true, we execute what's inside that if statement. What's inside? It's the stuff that's indented. So return value equals a number divided by 2. So what is a number? 10. What is 10 divided by 2? 5. So where do I put that 5? Yeah, into return value. So return value did have the number 10, but we just obliterated it and replaced it with 5. And now we finish line 4. There's no other code in that if statement, in that block of code. So we finish. We resume outside where it's unindented. And we hit line 5. We return value, which is currently storing the number 5. So I get back the value 5. Perfect. If I call it with negative 10, well, here's how it would go. A number is negative 10. Return value is negative 10. Is a number greater than 0? Is negative 10 greater than 0? False. We skip all that code. We jump down to line 5. We return value, which is negative 10. That's how it goes. Notice that right now, it's just like a detour. The code is running like this, right? It's got this like normal flow. But if, like, and these are like, okay, step 1, step 2, step 3, step 4, let's say, right? I don't care how many steps there are in that function. But if that condition is true, we go over here, run something else, and then come back. So it's just like, do I have to do this extra step or not? That's what's happening, right? When that condition is true, we do this extra step, and then we meet up at the same place, whether or not it would have run or not. Yeah? Happy? Sad? Good. So that's like what's going on here. All right. Yeah, it's explaining it. Cool. All right. So have fun. Write a number is negative. Yes, do this activity. This is fun. Because chances are I'll get to make fun of everyone in here after. Write a function is negative that returns true if a number is negative and false otherwise. Write that function. But try to be smart about it, because I'm going to try to make fun of you after, and I want to see if anyone can impress me. For the purpose of time, don't worry about writing the tests. We'll do that after in a moment. Well, here, I'll write some tests now. Raise your hand if you're done. Raise your hand if you'll be done in like 30 seconds. Raise your hand if you're worried about me saying I'm going to make fun of you. Don't worry, I'm being silly. I mean, I'm going to make fun of you, but, you know, don't worry. Who here wrote it like that? No? Really? No one? Oh, it's usually what I expect. So who wrote it but did it differently? What did you do?
I broke the law and used an else statement.
Nope, you broke the law. Get out of here. You can stay. Anyone? How else did somebody do? What did you do?
So I had if the number is less than 0, return true, and then in the line below that, if the number is greater or equal to 0, return false.
Okay, so you just added another if. Okay, yeah. Which is kind of a roundabout way of doing the else, but we never learned about an else. So, okay, that's both very valid, very valid. What'd you do?
Value equals a number less than 0, and then return value.
Ah, see, I don't get to make fun of you because you did it the way that most programmers would do it. I'll show you that in a moment. Now, of course, I'm being really silly when I say I'm going to make fun of you. I'm just having fun. Because there's actually a lot to unpack here. Because there's a lot of different ways I can go about coding the solution. So first, I hit run, and this passed just fine. The asserts didn't fail. Let's follow this code. If, okay, def is negative, takes a number. If a number is less than 0, it's negative. I return true, right? Then outside the if I have return false. Now this is a little weird, and we did talk about this before, but we never really saw it in action, so I'll explain it a little again. When a function is running, only, like as soon as a return statement is run, the function immediately stops and will not continue running anymore until it's called again. So, let's run two scenarios. I give it the number -1. A number is -1. Is a number less than 0? True. So we go inside that if statement and I hit return true and the function immediately stops running. You might say, yeah, but it should run line 4. No. As soon as a function hits a return, it immediately stops. And it's done. If I call it with the number 1, a number 1, that's not less than 0, so it's false. A number less than 0 is false. We do not go inside. We go to the next line, which is line 4. And it says, basically, because the if statement was false, the condition was false, we skip all of the stuff in the if and continue after the if. And we hit line 4 that says return false. Cool. Right? Now you used an else, which is kind of more or less doing the same thing. And you used another if statement that basically, so let's start with what you did. You said if a number is greater than or equal to 0, is that what you have? Perfect. And if we hit run, this will work just fine. And note, I had two different pieces of code and they are functionally equivalent. Because remember, how many ways are there to solve a problem? An infinite. Well, here's 2 of infinity. Now, one thing you might notice, and we will talk about this as we carry on in the topic, this is equivalent to this, though, right? Is a number less than 0? Is a number like not less than 0, you know. It's the same thing, right? So that works as well. Cool. In fact, I'm pretty sure I don't need the parentheses here. Let's test it. But I'm always panicked about order of operations, so I usually throw in parentheses because I think it might make the code a little clearer. But whatever, that's fine. Now, we will talk about this shortly, but someone here who self-admitted cheated. This pattern right here, where I say like if condition, if not that exact same condition, is so common that programmers have come up with like a shorthand for that. If something, if not that something, we write else. Right? We jumped the gun a little bit down this topic, but that it's equivalent, right? Do this or this, right? So what's a little different is, remember before I showed like we went like this? Like that if, let us do like an additional step if we wanted. When you do an if-else, it operates a little bit different. It'll be more along the lines of something like this, where you go down one of two paths. Okay? Cool. But all of the solutions I've shown you so far are, I don't know if the word is silly, but let's say kind of silly. I want to be clear. I think this code is very clear. It's very explicit. But this particular function is kind of like writing this function this way is kind of like a meme in programming, right? And you fell for it. And the reason you fell for it is because, well, we just started talking about ifs, and I just showed you an example of how you could use an if to check if something is positive. So obviously, we're going to use the if. But we can do this without an if. And you know what? You've already done exactly this without an if. Let me show you what I mean. Is a -1 less than 0? What is that going to be? When I call this function, when I call this expression, what does it evaluate and give me? True. What about that? False. Did I need an if to say true or false? No. What I mean is, let's think about this for a second. And if you're like, wait, what? You're trying to be too smart. Programmers are stupid. We have to do one step at a time. Stop trying to be smart. Okay, I give it the value -1. A number is -1. I ask the question, is a number, -1, less than 0? True. Who said yes? God damn it, now you're just doing it on purpose. Yes, -1 is in fact less than 0. So when a number less than 0 evaluates to true, what do we return? True. When that expression evaluates to false, in an example like if I give it the number 1, is 1 less than 0? False. What do I return? False. So I'm saying if true, return true. If false, return false. Or we could do exactly what he suggested, which was, I know you assigned it to a variable, but just for brevity, I'll do this. We don't need this. We don't need this. We don't need that. There. That's correct. Now, all possible combinations of what I showed you are all fine. If you wrote the previous ones on a test or an assignment, all that will happen is the marker will chuckle to themselves and carry on. If this was like 5 years from now and you get a job as like a junior software engineer, your colleagues, they're definitely going to make fun of you. They're not going to be mean. They're just going to be like, ah, you did the thing. Because, yeah, it's a bit of a joke. But it doesn't really matter. So if this is unclear, think about what's going on. There's no trick to it. What does the code say? I call is negative with the value -1. A number is -1. Is -1 less than 0? What do I return? I give it the value 1. Is 1 less than 0? What do I return then? I didn't need an if statement here. Now, if you were to say, you know what, I really like the if statements because I think it made the code more clear. Yeah, sure, fine, absolutely. Other programmers will still make fun of you because this is so much of a joke, but anyways. Any questions about that? Cool. All right. Compounding conditions. So when we make use of an if statement, all that the if really cares about at the end of the day, so you're like, oh, this is asking if a number is less than 0. Well, actually, no. Now let's go back here. Now it's asking, is a number less than 0? Well, yes and no. In aggregate, that's what that line of code is asking. But all that if statement cares about is the Boolean value. True, false. If true, run it. If false, don't run it. If I wrote a line of code that said if true, this line of code will always run. Because all that the if statement cares about is that the value next to it is true, and if it is, it runs that block. Otherwise, it skips it. That's all it cares about. So although the question is, if a number is less than 0, yeah, but really what we're asking is a number less than 0, true or false? True? Run that code. It's the final result of that question that matters, not the question itself. It sounds like I'm saying the same thing, and yes, I effectively am, but that nuance is important to understand that all that if cares about is it true or false? Which is it? Therefore, I could make this expression as crazy complex as I want. So I can say something like this. 3 divisible 5. I showed you the percent sign operator before, right? For those of you that don't remember, it's just like remainder, right? Do the division, what are you left with? So if I say, what's 5 divided by 2? You say, oh, it's 2.5. Well, yeah, but that's like a float. If I were to say, okay, what's 2 divided by, like go back to like grade 2 when you first learned division. You didn't deal with decimals then, right? You dealt with remainders. So you'd be like, well, how many times can I get 2 out of the number 5? 2 times. What are you left over with? 1, right? So when I ask the question, let's just make sure the camera's still working. Nice. So if I go down here and I say 5 mod, here, let's do integer division. 5 divided by 2, well, that's 2, but what's left over? Well, we know that's 1, and we can verify that by this. It's the remainder, right? We're left over with 1. So here I'm writing a function that checks if a number is divisible by 2 different values. And when I say divisible, I mean evenly divisible, meaning it divides perfectly. There's no remainders. So what I want to know is if a number is divisible evenly by 3 and 5, right? So if I gave this function the number 3, well, a number mod 3 is 0. How many times can I get 3 out of 3? Once. What do I have left over? Nothing. Great. How many times can I get 5 out of the number 3? 0. And how much do I have left over? 3. It's not evenly divisible. Okay, fine. So because both conditions aren't true, this whole thing is false. If false, we skipped it. The answer is nope. Cool. This will only return true if both conditions are true. And I can make this arbitrarily complex, though you shouldn't, but you could. So here I'm making use of like numerical operators, the modulo, the remainder effectively. I'm also making use of a comparison operator, equals equals. Are these values equivalent? And I'm also making use of those Boolean operators, specifically and. So there's actually a lot of different operators in here. But to me, that's a nice bite-sized Boolean expression. It's complex, but it's not too bad that you can't wrap your head around it. Is it divisible by 3 and 5? Great. What number would this work for? Any multiple of 15. Yeah, perfect. Cool. I thought you were about to say any multiple of 3 and 5. Yeah, thanks, asshole. Yeah. But yes, you're right. I jumped the gun. You're right. Any multiple of 15, including 0, I suppose, right? So, yeah, cool. Great. Any questions about that? Remember, all that matters in order to run that code inside that if statement is that the whole expression, it's going to get a value, assuming it is a valid Boolean expression that gets evaluated as true or false. When it gets evaluated to true, you run what's inside the if block. If it evaluates to false, you skip it entirely. Any questions or anything about that one?
What does mod do with negative numbers?
Let's find out. This is where things can get kind of weird. Right? So it actually comes down to what mod really is doing. Yeah, so it's not really it's a little bit more nuanced than that. Let's not worry about it right now. But fun observation nonetheless. All right. Mod, yeah, it effectively returns the remainder. Yeah. Cool. Okay, yeah. So, for example, if I gave it the number 15, it would evaluate, okay, so a number mod 3 and a number mod 5 equals 0. Well, 15 mod 3 is 0, 15 mod 5 0. Well, 15 mod 3 is 0, and 15 mod 5 is 0. True and true, well, that's true. So all of that number crunching happens, and it all gets boiled down to a single Boolean value, true, false. Since the expression is true, we run it. If I gave it 9, well, it would come out to false. Alternative execution. Like we were just saying, it is so common where it's like if true, do this thing, false, do that thing. It's not if true, well then do that, and then carry on as if everything's normal. You actually come to a fork in the road. So it's not just a quick detour, it's an actual fork in the road where you're going to do one of two things. This is such a common pattern. For example, like if x is greater than 10. If not x greater than 10, do something else, right? This is such a common pattern that it's silly to write it out all the time. This is where we make use of the word else. And this is a good example, and I just talked about this today with you actually. This is an example of what programmers would call syntactic sugar. I'm not sure why they call it that. I think it's like a play on like, oh, it's sweet. I don't know. But this is syntactic sugar. Basically, those two things mean the same thing, right? But one of those two things is a little easier to write. So we like things like that. When the syntax to communicate to the computer something is just a little bit more natural and nice, that's like syntactic sugar. So else is an example of like syntactic sugar. Instead of saying if some condition, if not that same condition, we could just say if else. It means exactly the same thing. And I don't mean like, oh, it's effectively the same thing. I mean like as far as the computer's concerned, it gets turned into literally the same thing. It's just the fancy syntax that we use, and it's a little nicer. That's all. Here we go. Write a function called hail. We're going to do this activity. Write a function called hail that takes an integer as an argument. If the integer is even, return the value of that integer divided by 2. If it's odd, return the value multiplied by 3 and with 1 added. That's all just a really obnoxious way of saying, in other words, give it a number n, return n divided by 2 when it's even, and 3n plus 1 when it's odd. Don't forget the mod operator. Let me put it this way. If you're thinking, how do I check if something is even or odd? If something is evenly divisible by 2, is it even or odd? Even. So if some number divided by 2 gives you 0, it must therefore be He's right. If it's division, if it's mod, if something divided by 2 has a remainder of 1, it's therefore yeah, right? A number that, if you ask, hey, is the number, if I try to divide a number by 2, it can only either be divisible by 2, evenly divisible. Here, let me show you. In case it's not obvious. 4 mod 2 is 0. 5 mod 2 is 1. Is it ever possible to get a remainder when doing like division by 2? Is it possible to get a remainder of more than 1? Because if you had a remainder of 2, it wouldn't be a remainder. It would just be another like division of 2. Yeah. So even odd checks are pretty easy like that. So if I go to 6, I don't get a remainder of 2, I get back to 0. So this will just bounce between 0, 1, 0, 1, 0, 1. So here's my solution. Did anyone do it wildly different? I used an else. I could have done if x mod 2 is equal to 1. There. I could have done it that way. And someone might argue this is better because it's a little bit more explicit about what you really care about and the intention behind the code. Yeah, fine, that's fair. But they mean the same thing. Like I showed you, but you could do not x mod 2, 0. Yeah, that would work too. Although this one, I think there's a harder argument to be like, well, is it really communicating more? I don't know. It's up to you. By the way, has anyone ever gotten to a situation where you've just done 3x like that? And it's like, no, you can't do that. Yeah, you can't. Python's not smart enough to know what you mean here. And you may have been in a position where you try to do like, I realize this is not the same thing, but let's say you're like, well, I just want to multiply 3 to the result of that, right? If you try to run that, this ain't going to work. If you really wanted to do something like this, which again is not what I was asking you to do, I'm just showing you an example, you'd have to explicitly say multiply. Python's too dumb. Because otherwise, it thinks like, oh, you've got parentheses. You're calling a function. You're calling the function 3. 3 is not a function. It's a literal. I can't do that. And that's literally what Python's going to say. I'll show you what I mean right here. If I go down here and say like 3 times 4 plus 2, and I hit run, it's going to be like int object is not callable. You can't call, it's an integer, it's not a function. You can't call this. Yeah, because it means something different. Now, I showed you smush before, where I wrote it like it was operating like this, right? Where we made a decision, and we went here and we returned, or we carried on. No, that's actually not right at all. Where we did an extra step, and then we came back, and then no matter what we returned. That's how I wrote smush the first time. Here, I've rewritten that exact same code, but it actually has a little bit of a different flow. It's written like this, where it's going and doing this or this, but then it comes back together and then ends down here. But they're functionally the same. And I could even write it another way, where people say like, you know, I can write it like this, where we go, we make a decision, we come down and we return over here, or we return over here. Either way, we didn't need to come back together. It's entirely fine. They're all the same. Which one is the best one to write really comes down to style and design decisions. Some people would love this one. Some people say, you know, it's better to have a function really only have one return statement. It's better to do it that way. I don't prescribe to that philosophy, but some people really strongly believe in that. Okay, fine, yeah. Because you could write the function to operate one way or the other. It's fine. You're not limiting yourself. Other people like me would be like, yeah, I don't give a shit. You can have as many returns as you want. I don't really care. Some people will look at both of these and be like, you know, here, you know, I don't like that you're assigning a value in the if statements before it's ever defined. It'd be better to have return value defined outside the ifs. It all comes down to design decisions in the end. Any last questions? All right, I'll see y'all later.